Hi, we're going to review the solving quadratics by factoring and solving quadratics by quadratic formula practice test from Edulastic. So number one, it says what is another word that describes the zeros of a quadratic function? Remember there's lots of words and x-intercepts is one of them. So is zeros, solution, roots, those are all other options as well. So in number two, we had to do a lot of factoring. The main thing that you want to pay attention to is that the first term and the last term are perfect squares. So I'm going to kind of write that out over here on the margin, perfect squares. And so we have to think about, well, do they fit that pattern of a perfect square trinomial or a difference of two perfect squares? Let's find out. So in this one, the middle term is negative, so I know that my first term, because it's a perfect square, would be 3x, and my last term would be 1. My first term again would be 3x, my last term would be 1, but because the middle sign is negative, that means both these terms would be negative. So the way that we know we did it right is by distributing. So 3x times 3x is 9x squared. 3x minus 1 is negative 3x, and then another one would be another negative 3x. So negative 3x minus 3x is negative 6x, and negative 1 times negative 1 is positive 1. So that works out. The other thing to keep in mind is we had a formula that said you had a squared plus or minus, depending on the sign of the middle term, 2ab plus b squared. So that was the formula that we used for the perfect square trinomials. So 2 times a is 3x, and b is negative 1. So 2 times 3 is 6, times negative 1 is negative 6, so it works, it matches, it's a perfect square trinomial. So again, that answer was 3x minus 1 and 3x minus 1. And yes, you just have to pay attention to the answer choices. It is also 3x minus 1 quantity squared, but in our case it wasn't one of those solutions, so then it's just this one for now. Okay, next one, this is a difference of two perfect squares, so it'd be 3x minus 1, 3x plus 1, so that the middle terms can cancel out. The next one, notice that they are perfect squares, first and last term, but it's not the difference of two perfect square, it's the sum. You cannot factor the sum of two perfect squares, only the difference, because if it's plus, that means we have to have something in the middle term, which doesn't exist in our case. The next one, we have difference of two perfect squares again. 4 and 9, any even exponent are all perfect squares. So if I take the square root of the first term, you'd get 2p. Take the square root of the second term, you'd get 3q. Okay, and then we do the same thing, but we switch the signs so that the middle term can cancel out. So that would be this one. And then purple, notice that we have the perfect squares again, first and last. And then if I take the square root of the first term, that's 2x, and the square root of the last term is 1. So 2x times 1 is 2x, times 2 is 4x, because I'm using this formula to check to see if it's a perfect square, and it is. So that means it would be 2x plus 1 and 2x plus 1 again. Okay, and again, that's the same thing as writing 2x plus 1 squared, but in our choices right now, they don't have it as a quantity squared. So the last one that we're going to take a look at is this one, and since it has 4 terms, we're going to factor by grouping. So out of the first group, we can take out a 2x, and you're left with 3x minus 2. And out of the second term, can't take out anything but a plus 1, because we want to leave parentheses 3x minus 2, which is the same as the second parentheses. So one factor is 3x minus 2, and then the other factor are the two GCFs written in front. So we want to find that solution, 3x minus 2, 2x plus 1, it's this one. So then we know we did it right, but I think they had the 2x plus 1 first, 3x minus 2. Okay? So number 3, we have to figure out two numbers that multiply to equal negative 30 add up to 13. So we know 15 and 2 add up to positive 30, but one of those has to be negative. So if I start with a positive 15 and a negative 2, those would add up to 13. Number 4, we have to factor this by subtracting 3 on both sides first. So you have x squared minus x minus 2 equals 0. And then when we factor that, we have to find factors of negative 2 that add up to equal negative 1. So that would be negative 2 and positive 1. So we have x minus 2 times x plus 1 equals 0. But we have to solve it. It's asking for you to solve, which means solve for x. So that means x minus 2 is equal to 0 and x plus 1 is equal to 0. When they say zero product property, all that means is that each of these have to equal 0 because something times 0 has to equal 0. So that means x equals 2 and x equals negative 1. Next one, we have the factor. So notice that this only has 2 terms, so this means that you have a GCF. So pay attention to the GCFs. In our case, it's just x. So we can take out 1x and we're left with 7x plus 2 is equal to 0. Same thing, both of these have to set equal to 0. So one of our answers is 0, and then we have to set this other one equal to 0 as well. And so when we do that, we subtract 2 and divide by 7. Okay. Okay, that's it for that page. Next one, factor. Again, we have to put it in standard form, so we have to subtract the 9. So 3x squared minus 26x minus 9 is equal to 0. Multiply first and last terms together to get negative 27, and then the factors that add up to negative 26 would be negative 27 plus 1. Okay, so this is where we're going to be rewriting the factors and factor by grouping. So we'd have 3x squared minus 27x plus x minus 9. And then we can go ahead and factor by grouping. So we have a 3x to take out, and you're left with x minus 9. And then we're going to factor out a positive 1 to keep the x minus 9 the same. And you're left with 3x plus 1 times x minus 9 equals 0. So a couple things to think about is if you have a quadratic, that means at most you'll have 2 solutions. So we know it can't be C or D. Okay. So then we just have to solve this and see if it's one of the 2 choices. So x is equal to 9. And if I set this equal to 0, you get negative 1/3. And that is one of our choices. It's B. So that answer is there. What's the purpose of the quadratic formula? Is to determine the zeros of the quadratic function. We're trying to figure out where does it cross the x-axis or the x-intercepts. This one we have to actually plug in or drag and drop all the parts into the quadratic formula. So you have negative b plus or minus b squared minus 4ac all over 2 times a. Okay. Number 9 says for the equation below, find the discriminant. And actually, these are the last 3 questions, and these last 3 are the ones we need to solve for the quadratic, or solve using quadratic formula. So we have to find the discriminant. Discriminant, again, was b squared minus 4ac. And so we have this in standard form. So we have a equals 2, b equals negative 12, and c equals 18. We plug those in. So it would be negative 12 squared minus 4 times 2 times c, which is 18. This is a 2, not a d. Okay. So negative 12 squared is 144. 8 times 18, 144. And 144 minus 144 is 0. Because the answer is 0, it means that there is one real solution. And then we have to plug that in. So into the quadratic formula, we have negative b, or the opposite of b, so if it's negative now, it becomes positive, plus or minus square root of 0 all over 2 times 2. Well, we know square root of 0 is 0, so we're left with 12 divided by 4, which is 3. And remember, there's only one answer. That's it. So in number 10, we have to rewrite this in standard form. So you have 8x squared plus 6x plus 5 equals 0, where a equals 8, b equals 6, and c equals 5. So finding the discriminant, I'm going to do my work down here, so I have a little bit, actually I might be able to squeeze it in here. That would be 6 squared minus 4 times 8 times 5. And so that would give us 160, or negative, yeah. So it'd be 36 minus 160, and that would give us negative 124, which means there are no real roots or 0 real roots. So then we have to plug that in and solve. So we have opposite of b, so that would be negative 6 plus or minus square root of negative 124 all over 2 times 8. Negative 124 breaks down into factors of negative 1. So the perfect square is 4 31 times. So that comes out to 2i times 31. So if we clean that up, rewrite it, you have negative 6 plus or minus 2i times square root of 31 all over 16. Because my coefficients are all even, I have a negative 6, I have a 2, and a 16. We can simplify that one more time. So we'd have negative 3 plus or minus I times square root of 31 all over 8. And this is my final answer. So I'm going to just box my red answer down here, then trying to write it in that little box. And then finally the last one. We have to rewrite that in correct standard form. So it'd be 2x squared minus 8x plus 7 equals 0. And it doesn't matter if you put where a is positive or a is negative. It should have taken either answer. So in this case, a is 2, b is negative 8, and c is 7. If you have your switches, your sign switched, because this was switched, that's okay. Your final answer should be the same anyway. So let's go ahead and solve the discriminant. So we have the opposite of b, b squared minus 4 times a times c. So we have 64 minus 56 would give us 8. And then because the discriminant is positive, that means there are 2 real solutions. And then we just have to solve for it. So we have the opposite of b, which is now 8 plus or minus square root of 8 all over 2 times 2. So if we simplify the square root, we know that 4 is the perfect square with 2 left over, so that simplifies to 2 radical 2. So let's go ahead and rewrite that. So we have 8 plus or minus 2 radical 2 all over 4. Notice that I can do a little bit of simplifying here because my coefficients are all even. 8 divided by 4 is 2 plus or minus, but then this second part remains a fraction because 2 over 4 is 1/2, so it'd be radical 2 over 4.